Okay, so we've been working with laws of logarithms and changing logarithms into exponential form and exponential form into logarithm form. So we're going to use all that to solve log equations, which is the whole point of doing everything we've been doing. So to solve log equations, basically what we need to do is get the log by itself on one side and everything else to the other, and then set it up as an exponential equation and solve it. So number one is already set up to where the log is on one side and the 2 is on the other. So all we're going to do is rewrite it as an exponential equation. So if we do that, it would become 7 squared equals x. So x must be 7 squared, which is 49. So x equals 49. That was pretty easy. All right, number 2, we have log base x of 27 equals 3/2. Again, our log is by itself, so just rewrite it as an exponential equation. So it would be x to the 3/2 equals 27. All right, so I have x to the 3/2 equals 27. That I could probably figure it out, but why should I need to? Because I know how to solve this. I'm going to raise this side to a power that will get rid of the 3/2 power. And what is that power that would get rid of that? That's right, it's 2/3. We do the reciprocal of it. So then I have to raise this one to 2/3. And remember, since I'm raising it to a power with an odd denominator, I'm only going to have one answer, not two. These two right here kind of cancel. The 3 and the 3, the 2 and the 2 cancel. So it just leaves you with x. So x is going to equal 27 to the 2/3. That means the cube root of 27 squared. Well, according to my chart, the cube root of 27 is 3. So x equals 3 squared, which is 9. So x must equal 9. Make sure you ask questions if you have any. All right, number 3, we have log base x of 2 equals 0. So we have our log by itself. We're just going to rewrite it as an exponential equation. So it would be x to the 0 equals 2. Well, what is x to the 0? What is anything to the 0 power? It is 1. So 1 equals 2. Well, wait a minute, 1 doesn't equal 2. So no matter what x is, if I raise it to the 0 power, it's going to be 1. And 1 is never going to equal 2. So therefore, there is no solution to this one, because nothing to the 0 power is going to equal 2. All right, number 4, log base 2 of 64 equals x. My log's by itself. Just rewrite it. So it would become, sorry about that. It would become 2 to the x equals 64. All right, well, my chart doesn't go that high. The highest it goes is that 2 to the 5th power equals 32. But if I multiply 32 by one more 2, I get 64. So it must be that 2 to the 6th power equals 64. So x must equal 6. And remember, we are solving for x, so your solution should be that x equals some number. Please don't leave your answer like this and then circle this 6. I want your answer like that, please. All right, number 5, we have log base 2 of x minus 9 equals 4. This is still just a plain old log, so we're going to just rewrite it in exponential form. So it would become 2 to the 4th power equals x minus 9. Well, 2 to the 4th power, according to my chart, is 16, so that means that x minus 9 equals 16. I'm going to add 9, and x equals 25. Make sure you're asking questions if you're not sure about something. All right, number 6, 15 plus 2, log base 2 of x equals 25. This is the first one where the log is not by itself to begin with. So we need to get that log by itself. So the first thing I'm going to do is subtract 15 from both sides. And I am going to get 2 log base 2 of x equals 10. All right, my log is still not by itself because there's that 2 in front of it. So to get rid of that, I'm going to divide by 2. And I am going to get that log base 2 of x equals 5. All right, now my log's by itself. So now I'm going to write it as an exponential form. So it will be 2 to the 5th power equals x. Well, 2 to the 5th power, that's on my chart. And x equals 32. Make sure you ask questions if you're not sure. Okay, so number 7 is interesting because I have logs on both sides of my equation, of my equal sign. I want all my logs to one side and then all the other numbers to the other side. So basically I need to take this log that's on my left side and move it over here. Well, in front of that log is a negative sign, so it's a negative log base 8 of x. So if I move it to the other side, it will become positive, right? And then I need to take that negative 2 and move it over to this side. Well, if I move the negative 2 to the other side, it will become, over there, positive 2. So I'm going to have log base 8 of 4 plus, because remember we moved that negative log base 8 of x to the other side, it became positive, log base 8 of x equals positive 2, because when I moved the negative 2 over, it became positive 2. All right, so I have 2 logs on the left side, and I can combine them into one log, and I need to do that. So addition on the outside of a log becomes multiplication on the inside. So it's going to become log base 8 of 4x equals 2. This is what we did yesterday. We worked on combining logs together and putting them all in one log, and then we worked on separating them also. All right, so now I've got one log equals something else, so I'm just going to write it as an exponential in the exponential form. So it would be 8 squared equals 4x. Well, 8 squared is 8 times 8, which is 64, equals 4x. I'm going to divide by 4, and x equals 16. Make sure you stop me and ask questions. All right, so number 8 is the last one. Again, I am going to move all my logs to the one side and all the other numbers to the other. So this log right here is going to move to this side, and it's going to become what on the other side? Negative is correct. So I'm going to have 2 log base 4 of 8 minus 2 log base 4 of x. And then I want to move that negative 2 to this side, so over on that side it's going to become positive 2. Okay, now you notice that both of these logs have 2's in front of them. I want to get rid of those. So to get rid of both of them, I can just divide by 2 because it's going to cancel with this one and this one. It's like I factored out a 2 in front. I could have written it like this: 2 log base 4 of 8 minus log base 4 of x equals 2, and then divided by 2. That's basically what I did. Okay, so I am going to get log base 4 of 8 minus log base 4 of x equals 1. 2 divided by 2 is 1. All right, so if I combine log base 4 of 8 minus log base 4 of x, minus on the outside of a log becomes what on the inside? It does become division. So I erase that so I'd have more room. I'm going to end up with log base 4 of 8 divided by x equals 1. All right, now I have a log equal to a number. So write it as an exponential form. So 4 to the first equals 8 over x. Well, 4 to the first is just 4. All right, I can do this a couple of ways, but I'm going to do this this way so that everybody can understand. I'm going to multiply by x to get that x out of the denominator. So I'll end up with 4x equals, these are going to cancel, 8. Then I'm going to divide by 4, and I get that x equals 2. And that would be my answer. Make sure you ask questions if you're not sure how I got that answer.